Hello friends, in this topic, in the analysis of radiation, we have seen so many laws. Now in this topic, we are going to talk about the Kirchhoff law, which talks about the absorptivity and emissivity of a given body. Now let us see what we have. The law of radiation, that is the Kirchhoff law. The statement for the law of radiation, which is the Kirchhoff's law in this topic, it states that the emissivity of the surface is equal to its absorptivity when the surface or the body is in the thermal equilibrium with its surrounding. Now this is the statement of Kirchhoff law. Basically it talks that if a given body or a system is in the thermal equilibrium with the surrounding, then the emissivity of the surface is same as the absorptivity. Conditionally, the temperature is kept constant, which is, let's say, at temperature T. So for the proof, what we can do, we can consider there is a black body or a black surface which is kept at temperature T. Then there are two bodies. Okay, the specification of the bodies are the area is A1, the emissivity is, let's say, E1, and then the absorptivity is, let's say, alpha 1. Similarly, the same can be said about the body 2. Let us assume that the other space inside the black surface is basically vacuum. So we will make sure that the only way by which the heat transfer that will take place is only by radiation. No conduction or convection will be involved. Now if this is the case, then how to do the analysis or how to look at the proof? Here we need to prove that for a given surface, the value of alpha, that is the absorptivity, is same as emissivity. Now let us start the proof of the same law. As we have seen previously, we had two bodies which are kept inside a black surface. Now what we can claim about those bodies is that, let's say for the first body, the rate of energy absorbed is equal to the rate of energy emitted. See here, for this body we can say that the rate by which the energy is getting absorbed is same as the rate by which the energy is getting emitted. So this can be mathematically expressed as I into alpha 1 into A1, where A1 and alpha 1 are nothing but the area of the body 1 and then the absorptivity of the body 1. And I is nothing but the incident radiation. So let me write somewhere here. So whatever I amount of energy that is coming onto the body 1, out of which the alpha amount of energy is getting only absorbed. Now this energy is same as the rate of energy emitted. So which is obviously given as E1, that is the energy emitted into the area 1. So with this I can write down that I is equal to E1 upon alpha 1. Similarly, I can write down the same equation for body 2, which is I into A2 alpha 2 is equal to E2 into A2. Again, this is the rate of energy absorbed on body 2, which is equal to the rate of energy emitted by the body 2. Now again here I can rearrange the terms and I can write down that I is equal to E2 upon alpha 2. Now from this equation number 1 and 2, we can write down that I is equal to E1 upon alpha 1, which is equal to E2 upon alpha 2. Now this itself can be expressed as, now this is given for black body, so this itself can be written as EB upon alpha B. But for black body, the value of alpha B is always unity. So this can be easily expressed. Instead of 1 and 2, I can, for a common, I can write down E upon alpha is same as EB. So what is alpha? Alpha can be written as E upon EB. Now this is, we can say that this is equation number A. Now let us define what is absorptivity. It is nothing but the amount of energy that is absorbed upon the total amount of energy. Similarly, let us define what is emissivity. It is nothing but the amount of energy emitted by the given body upon the amount of energy emitted which is kept at same temperature by the black body. Now as per the definition and from equation 1 or equation A, we can say that we have got already that E by EB is nothing but alpha. Now this is E. So from this equation, these two equations, we can easily claim that the emissivity is same as the absorptivity. Now this is what we can say as proved. This is the Kirchhoff law. One very important modification that need to be understood is that the correct statement should be, in case of Kirchhoff law, the energy or the emissivity of the given body or the surface is same as the absorptivity of the surface, conditionally that there is a thermal equilibrium, means the temperature everywhere is kept constant, and the second thing is the wavelength is also kept constant. So this makes it perfect that we need to consider about the wavelength. Similarly, one more addition can be done is that along with the wavelength, the direction is also considered as a same. So here we can say that for same wavelength and same direction, means you have to understand that there is a surface on which the amount of energy that is impinges is having the same wavelength and direction as the surface is emitting. So basically the wavelength and the direction of the radiation for the surface is same in case of emission and absorption. So the best application of the Kirchhoff law is nothing but the black body approximation. Now let us talk about this. As we have seen before, it is really difficult to have a body which is same as the black body, or practically it is impossible to have a black body. But using the Kirchhoff law, we can consider a cavity. Let us consider this kind of a cavity. See, on this cavity, let us assume that the inside color is it's a lamp, black color is there. So whatever, now again you have to imagine that it's a very thin cavity. Okay, so whatever energy that is coming onto this cavity from the small slit is getting entire absorbed by the surface itself. So no energy will get emitted. So in this case, all the energy that is coming onto the inner surface of the body is getting absorbed, or either it will be absorbed or transmitted, but we will make sure that no energy is going out. Now in this case, the absorptivity of the given body is same as the emissivity, and we can also assume that since entire energy is getting absorbed by this body itself can be approximated as a black body. Now this is simply a application of the Kirchhoff law, nothing else. One more thing that need to be said about the Kirchhoff law is that even though it is only theoretically what we have seen is alpha is same as emissivity, the same has been confirmed experimentally. So this is not the ideal experiment, or this is not something which is hypothetical. Experimental also we have seen there are so many experiments that they have performed and they have concluded that for a given surface the value of alpha is same as the emissivity. One more thing is that as the value of absorptivity varies from 0 to 1, so will be the value of emissivity varies from 0 to 1. Now, there are so many other things that we can conclude out of the Kirchhoff law, but we will restrict ourselves to the academics. Now, that is all in this video. In this video, we talked about the Kirchhoff law and its application. Thank you for watching this video. Please stay tuned with eKida and subscribe to eKida. Thank you.